that there's a universal now. That if it's 12 o'clock here, it must be 12 o'clock on the moon, and by golly, it must be 12 o'clock throughout the entire universe. Actually, in reality, it is impossible to synchronize your watches throughout the universe.
This is because of misconception number 2. Many people believe that time passes at a constant rate.
People also believe that time ticks uniformly throughout the universe. Actually, that's not true. You can show that in outer space, a clock actually ticks slower than on the Earth.
In order for our satellite navigation systems to work, the U.S. military has to make corrective adjustments to the satellite clocks every single day. Time is not absolute. It ticks at different rates in different places. The time traveler must discard any notion of mechanical time. And embrace the idea of Think.Ku has a way of helping us. Computer games.
What is so fascinating about Pac-Man is that Pac-Man lives in 2 dimensions. He can only go forward, backward, left, right, but the concept of up is totally alien. They cannot visualize the concept of up. They live in a flatland. Now, we also live in a 3-dimensional world. We go forward, backward, left, right, and up, down. But we are incapable of visualizing a higher dimension, a 4th dimension. That requires a leap of logic that our brain simply cannot comprehend.
To find a location on Earth. But unlike Pac-Man, we can leave the 2D flat world. We also live in a building on a building, but also, in fact, the 4th dimension of time is so interwoven with the other 3 dimensions of space that physicists now have one name for the 4 dimensions altogether. Space-time.
We now believe that space and time are not invisible. They're actually a fabric that can be stretched, pulled, and perhaps even wrapped up into knots. If so, then perhaps the dream of time travel is not as preposterous as it sounds.
To build a time machine, we must find a way to manipulate this space-time fabric. Many scientists believe that it's this manipulation that will make time travel not only possible, but inevitable. We know how to change the speed we move as we rush along a busy sidewalk, but changing the rate we move through time is much more complicated. Most of us move forward in time at a rate of 1 second per second, but there are already time travelers among us. Astronauts on board the International Space Station have time traveled into the future. But how have they managed to do this? Space stations orbit the Earth at more than 17,000 miles per hour. Men and women have lived on them for more than 700 days. Upon their return, the astronauts had traveled a fraction of a second into the future. Their primary method? Speed. A spaceship is a time machine. The speed at which it travels is slowing down time for the people on board. To demonstrate how